Hey, Wagwan. Yeah, man. It's Mr. Garfield here, and we're going to be looking at a CSEC Mathematics past paper question, right, from the January 2020 paper 2. Okay? Now, the question says the diagram below, not drawn to scale, shows a triangle MNP in which angle MPN is equal to angle PMN, all right, and both of those are equal to 52 degrees, as you can see from the diagram. And the length of MN, right, that's the length of that side is 12.5 centimeters. And it says we are to state the type of triangle shown above, determine the value of angle PNM, and calculate the area of the triangle MNP. Okay, let's do part one here to the side. Part one solution. It says that we are to state the type of triangle shown above. Okay, now what type of triangle is this? As you can see, it told us that angle PMN is equal to angle PMN, right? So angle MPN is equal to angle PMN. Both of those are equal to 52 degrees. Now, what does that tell you? Immediately, you should recognize that this is a isosceles triangle, all right? It is an isosceles triangle. Okay, and what else can you see? Yes, what else can you see? You can see that the side MN is 12.5 centimeters in length, right? And we know the properties of the isosceles triangle states that the base angles must be the same, right? As you can clearly see, so it means that the side PN is the base, right? That side there is a base. And if the side MN has 12.5 centimeters in length, it means that the side PN must also have 12.5 centimeters in length. Okay? So part one, it's asked us to state the type of triangle shown above. And I can say that the triangle MNP is isosceles. All right? That is my solution. Okay? So it didn't ask us to state the reason, right? It never said to justify your answer, to give a reason or anything like that. So you can just leave that as it is. However, if it did, you'd tell them that the base angles are the same, right? And therefore, the side PN must be equal to the side MN, right? Good. Part two. All right, so we just used the properties of the isosceles triangle to answer part one. And part two, solution, it says to determine the value of angle PNM. PNM, so they're talking about this angle here. All right, this angle right there. Let's call it alpha. All right, I'm gonna call it alpha. And for the properties of the triangle, you should know that the sum of all internal angles of the triangle is equal to 180 degrees. Okay? So that is the property that I'll be using here. So let me just write a statement. All right, so the sum of all internal angles of a triangle is equal to 180 degrees. All right. So what I'm now saying is that if I should add all the three angles of the triangle, that's 52 degrees plus 52 degrees plus our unknown alpha, all right, that angle alpha. When you sum all of those angles on the left-hand side, it should be equal to 180 degrees, all right? That is what we are saying. Good. So our aim is to find the alpha. So we know that 52 degrees plus 52 degrees, that is 104 degrees. So we have 104 degrees plus alpha is equal to 180 degrees. All right, so we can now say that alpha is equal to, I'm going to carry the 104 degrees on the right hand side of the equation. It will become a negative. So alpha is equal to 180 degrees minus 104 degrees. All right. And therefore, alpha is equal to 180 degrees minus 104 degrees. That is 76 degrees. Okay. Alpha is equal to 76 degrees. So it means that I can now come here and write alpha is equal to 76 degrees. All right. And that is a solution to that question there. Good. So part 2 is now answered. Let's now answer part 3, which says we have to calculate the area of the triangle. All right. So part 3, solution. They want us to calculate the area of the triangle MNP. Okay. Now remember that there are different methods that we can use to calculate the area of the triangle. There are many, many different methods. All right. But the only one, at least that I can see, which is applicable here, is this. So I'm going to say that the area, of triangle MNP is going to be equal to the length of the side MN multiplied by the length of the side PN divided by 2, all right, divided by 2 multiplied by the sine of alpha. All right, good. So that is the formula that I'll be using. You probably might be familiar with the formula 1/2 multiplied by a times b sine c, right? That is the formula that I'm basically using here. Okay, so the area of the triangle is equal to, we know that the length of the side MN and the length of the side PN is 12.5 centimeters. All right, so we have 12.5 multiplied by 12.5. All right, and I'm dividing that by 2. Okay, this is 12.5. I'm dividing that by 2. All right, multiplied by the sine of alpha. We just calculated alpha to be 76 degrees. That is sine of 76 degrees. Okay, good. So this is now equal to what? If you should put this value into your calculator, all right, so I can now say that the area of triangle MNP is equal to, when you put that value into your calculator, you will get 75.80435362. All right. And remember now that we're dealing with area, which is squared units. All right. And our unit here is centimeters. So I can come over here and say squared centimeters. All right, squared centimeters. And that is my solution for part 3 of this past paper question. All right, and that is the end of this question. Okay, so I hope that this question was very helpful for you. If it was, please ensure to like up this video, all right, and comment down below. And if you aren't already a subscriber, please subscribe and share this video with your friends. All right, I'm Mr. Garth Reed, student ambassador in the University of Technology, Jamaica, and I'm a mathematics teacher in training in the School of Mathematics and Statistics. I thank you for joining.